What is life? And how could we find new forms of life? And how could we interact and communicate with them? For that and much more, let's go beyond with Dr. Graham Lau, an astrobiologist and communicator of science. He currently serves as the Director of Communications and Marketing at Blue Marble Space and as a research scientist with the Blue Marble Space Institute of Science and as the Director of Logistics for the University Rover Challenge. He also co-hosts the NASA-sponsored live stream show Ask an Astrobiologist, and you can find Dr. Lau on Twitter and Instagram at the handle @cosmobiologist or on his website cosmobiota.com. So let's go beyond with Dr. Graham Lau. Let's go!
Go beyond your horizons.
All right, here we are. Graham, good to see you here. Thank you for coming to the spacecraft.
It's a pleasure. Thanks for having me.
Thank you so much. So the first thing, I want to begin with, you are an astrobiologist. Some part of our audience may not be familiar with the term. Could you briefly tell us, what do you do as an astrobiologist?
I'm happy to. Astrobiology, bringing those terms together, astro for stars from aster, and biology from trying to understand life, the study of life. Astrobiology is humanity's quest to understand the nature of life in the cosmos. It's a very large field that brings together people from many different backgrounds. And so for me, myself, I started off with degrees in biology and chemistry. I then studied astrophysics, and then I earned my PhD in geology, focusing primarily in geochemistry and mineralogy. But there are people involved in astrobiology who have come to the realm from astrophysics, from oceanography, from atmospheric sciences, from aerospace engineering, from biomedical engineering, from all these different fields. And one thing I really love about astrobiology is that it's more than just science as well. There are people involved in astrobiology who are philosophers, who try to figure out how do we define life? Can we define life? Why do we look for life in the first place? There are people who come to astrobiology from other backgrounds as well, from the humanities and social sciences, in trying to better help us frame this quest to understand the nature of life. And so even though my own personal scientific research background is in the realm of geochemistry, specifically trying to understand how we can use remote environments, polar environments on the Earth, as analogs for extraterrestrial environments and looking for life, there are folks who are astrobiologists who are doing all kinds of cool things in the realm of origin of life research, the evolution of life, looking for biosignatures on other planets, looking for technosignatures of other civilizations around other stars. And so astrobiology is a huge field with so many different kinds of ways to be involved.
Fantastic. You really give us a very clear picture of how vast, how huge is this field. So let's go now. Let's give you a little challenge. Let's go deep beyond on a little part of this huge area. Let's imagine that you have 5 minutes to study, to examine a new kind of biological life form. If you had just those 5 minutes, what is the first thing that you would analyze and why?
That's a very good question to go beyond with our research and what actually happens once we've found the life. A lot of us in astrobiology will talk about looking for biosignatures, for signs of life, and what we do chemically and geologically when trying to determine if we found signs of past or present life. But if we've just found a new life form and we're sure it's life, it's definitely a life form, we know for sure it's a life form. There's a few things that we would want to know. And if we only have 5 minutes, for some reason, say we only have 5 minutes to figure it out and then we have to leave. In those first 5 minutes, I suppose that from my background in biochemistry and geochemistry, the immediate things I would want to know is what is this thing chemically? So with 5 minutes that I have, can I get a sample of it, or can I somehow analyze it to figure out its elemental makeup? as quickly as possible. Other analyses will take much longer, like looking at isotopes and things like that. But if I only have 5 minutes, the very first thing I want to do is just take a look at it with a microscope, or if it's very small, or if it's a large being, just to have a look at it and see what it looks like. And then if I have any of that 5 minutes that I possibly can, try to get a sample of this material, I want to try to analyze it for its chemistry.
So you would want to see those building blocks, right? The building blocks, get to the building blocks of the thing.
If we can, yeah. Nice. I mean, it takes time. It takes a lot more than 5 minutes to usually do those analyses and see what molecules you're looking at. And so from a very basic standpoint, we'd be looking at it morphologically, what it looks like first, and then we start going into the chemistry.
Perfect. The shape and then the chemistry. Perfect. And another thing that a lot of people are curious about is communication with new kinds of life forms. So, of course, we are used to our kind of structure, carbon-based life forms, but there could be other life forms that are based on other chemical arrangements, right? For example, they are talking about the lakes of Titan with the methane lakes, where there could be other kinds of life forms. So the question is, if we ever come across with new kinds of life forms, how likely do you think it is that we may actually miss in our explorations that the existence of these other kinds of life forms, because they are configured, because they have different arrangements chemically to ours?
It's a very great question. And one place a lot of folks are looking right now is in the realm of agnostic biosignatures. So agnostic in the sense that there are signs of life that would be general, universal characteristics. So looking at isotopic abundances and things like homochirality, the left-handedness versus right-handedness of certain molecules. So there are some things we can do in looking for life and trying to understand life that isn't so presumptive for life as we know it. Now, we do have some reason to think that other life out there might share some very common characteristics. So for instance, life as we know it is carbon-based.
Yes.
We have a carbon backbone in almost all of our molecules. Carbon is very important for life as we know it. A lot of folks have talked for a long time about silicon-based life forms and whether or not that's possible. Silicon is just one row down on the periodic table. It's very similar to carbon. It can make 4 bonds the same way carbon does, and it can make a backbone.
So it's pretty similar in
very similar,
right?
Except the bonds between those silicon atoms are a little weaker than the bonds between carbon atoms. And so silicon's not as good for making biomolecules as carbon.
Because it's weaker, because the connections are weaker, the bonds.
Yeah, it's the energy between the silicon atoms is just a little bit less, and so it's a little easier to break those bonds. Basically,
it's less consistent.
Yeah, and so we have reason to think that carbon-based life forms might be more common than silicon-based life forms, but we don't have any other examples of life yet to really know. But when it comes to looking, for instance, in Titan, the surface of Titan is very cold. But you're right, we have this methanological cycle on Titan where methane and ethane, other hydrocarbons are going into the atmosphere and making a bunch of gunk and then raining back down and making these lakes of ethane and methane and other hydrocarbons. And so if we have a life form there and we want to figure out, what it is and how it's functioning, one thing we could do, we could look for metabolisms like we know them here on Earth, but in that kind of environment, they're not as likely. And so instead, we'll look for these more agnostic biosignatures, these signs of life that would be signs of life across the board. So starting kind of at the very basic fundamental nature of life, what is the chemistry? What is the abundance of elements, the abundance of isotopes? Are there chiral molecules? And if so, is there a predominant form of left-handed versus right-handed molecules? Starting off in those places could help us define life that is much different than life as we know it.
That's very, very interesting. These agnostic signatures that are a bit universal. Before I go to the next point, let's go a bit deeper there. But on a first step, on a first encounter, how would you discriminate? How would you interpret that you are in front of a new kind of a life form? I mean, it's about this missing or not missing it. I mean, could it be really in front of us somewhere and we would miss it because it just doesn't look like anything familiar?
It's a great question. I mean, it's possible, right? It's possible that we would miss it. In fact, some scientists have even wondered if we're missing some of the life here on Earth.
Oh, interesting.
So a hypothesis
Hmm.
was proposed sometime back called the shadow biosphere.
Oh,
Carol Cleland was involved in that. Chris Kaiba has done work on it.
very
This
interesting.
is the consideration of whether or not there's actually a shadow biosphere on Earth, whether or
Wow.
not there's living things on Earth that are different than life as we know it, that have such a different chemistry that we're actually not finding them. So a
No,
lot of
that
our
is
assays,
fascinating.
yes, I mean it's really interesting, right? Like, could there be other forms of life, especially like nanoscopic, very small
Hmm.
organisms that have a much different chemistry, so that we're not seeing, their cellular structure, we're not seeing their biomolecules because they are very different. It seems unlikely given what we know of the Earth, but it's not impossible. And so when we go looking for life elsewhere,
Wow.
that's one reason why we want to consider how we look for life. So
Mm.
the Viking landers, for instance, that went to Mars back in the 1970s,
Yeah.
the Viking landers had life detection experiments on board.
Right.
Famously, one of those experiments sent back an unconfirmed detection.
Right.
And some scientists still to this day think it did find potential signs of life.
Yeah, there is like a
Many-
controversy. Yeah.
exactly. And many others don't think it found signs of life.
Hmm.
But it's still worth kind of trying to understand. But one issue with our original attempts to see if there was life out there is we were looking for life exactly as we knew it, that would have a similar metabolism to metabolisms to life as we know it here on Earth.
Mhm.
And that's not maybe the best way to start looking. There
Mhm.
are many other potential pathways for metabolisms, many other kinds of biomolecules that we know are possible, let alone what we don't know are possible.
Exactly.
And so, yeah, it's possible that there's shadow alien biospheres that are dark to our detection methods. But again, that kind of goes back then to this basic idea that in life detection science, we
Mhm.
really want to ask ourselves: are we being too Earth-centric? Are we being too
Exactly.
centered on our biosphere? And how do we break past that, looking for these agnostic biosignatures to make sure that we're actually looking for the full potential suite of things that could identify alien life if it's out there?
This is fascinating. And is there in the scientific community, is there now like a bigger push, a bigger impulse to try to open our minds more to these different possibilities? Do you see a trend?
Oh yeah, absolutely. I'd say as astrobiology has grown as a
Hmm.
field, and more people have gotten actively interested and brought their backgrounds from these various disciplines
Other
into the
disciplines.
realm of astrobiology, as it's a
Hmm.
very large field. And so we have all these different people. Now that people are talking to each other, now we're starting to get a lot more opinions, a lot more ideas that can help us to kind of get away from being too Earth-centric.
I love it, and I love this the shadow biosphere concept completely. Okay, so connecting back to Earth, where you are right now, and not me. What is, and this connects with your job a lot, with your work a lot. What is the most alien-like place that you know on Earth?
Wow, that's a great question. So, my personal research for
Yeah.
my PhD, I did some research up in the Arctic on
Mhm.
Ellesmere Island. It's just near
Arctic.
Greenland, up in the high Arctic.
High Arctic.
So very close to the North Pole, about
Mhm.
500 miles shy of the North Pole.
Mm.
I did research at a place called Borup Fjord Pass.
Mhm.
So this is a valley that runs between two mountain chains, basically,
Very good.
on this island on Ellesmere. And inside of the valley is a glacier called a
Mhm.
coalescence glacier. So basically, glacial ice from the mountains on either side are coming down and
Mhm.
forming a glacier in the middle of the valley.
Okay.
And on the surface of that glacier, noticed as early as the late 1980s, but definitely the 1990s, via helicopter, some scientists looking down noticed a bunch of yellow staining on top
Oh,
of the ice. And it turns out that yellow comes from sulfur, the element sulfur on top of the
sulfur.
ice.
Yeah.
And so it turns out that there's springs that are coming up through the glacier or
Mhm.
just at the base of the glacier, and they're
Mhm.
bringing from the subsurface sulfide-rich waters. So sulfide has that smell of like rotten eggs,
Yes.
and it comes up to the surface, and when it does, it meets with the air, and then
Mhm.
oxygen from the air interacts with this sulfide and transforms it into elemental sulfur, pure sulfur, which is yellow in coloration. And so this is a great place for us to study how life in a very cold environment
Mhm.
uses sulfur and sulfur cycling for its metabolism, it also allows us to then kind of use that as an analog for the icy worlds of our solar system. Specifically, Europa is a good, very good analog for that. However, we have many other weird alien environments on Earth that we can find. There's deep underground cave environments that are way different than life as we know it here. Iron Mountain out in California has had acidities measured down to the negative values, so very acidic environments where life is thriving. There are super hot environments like the Darvaza gas crater, where it's a natural gas coming up out of the ground that was lit on fire by some scientists that's been burning now for over 40 years. And in this gas crater, there's organisms thriving in the soil at the bottom of this burning pit of fire. And then all over our planet, we have volcanic environments, deep sea environments, all these various places that are just so different than our backyards and our homes around the globe. And yet life thrives all around our planet in these weird environments. And so there's a bunch of really cool alien places to explore.
That is so fascinating that you guys have found life almost in any kind of environment, even in the most hostile ones. Graham, if we wanted to be proactive, to find new kinds of life forms, what kind of a strategy do you think has more chances? The kind of robotic probes being sent to other planets, the SETI, like the Search for Artificial Intelligence Institute program. What kind of strategies do you think have more chances? Also lasers with light. What do you think?
Yeah, so I might get in trouble with some of my friends here because everyone has their own favorite idea of where we're going to find alien life first, if it's out there. Personally, my biggest bet right now would be on exoplanets. So I even though I love our solar system, and I do think we should look, we should find out if there was life or is life on Mars. We should look and see if there is life in the ocean of Europa or life in Enceladus or Titan or all these other places, even in the clouds of Venus. There are a lot of places we can and should look and try to better understand, not even just for life, but for better understanding our solar system and our history here.
Our own home.
But when it comes to the search for extraterrestrial life, I think the biggest potential right now in the near future is in this discovery of exoplanets and understanding more about those exoplanets. When I was a kid, when I was born, we did not have confirmation that there were other worlds around other stars. It's only been in the last 30 or so years that we've started now detecting not just a few or tens, hundreds, now thousands of worlds around other stars. We know over 4,000 confirmed exoplanets right now. Personally, I think in the next decade or two or three, that number is going to start jumping up, and before long, we'll know of 10,000, 50,000, 100,000 planets around other stars in our very small neighborhood of the galaxy. And we have the telescopes now that we can start doing some chemistry. We can start looking at the atmospheres of some of these planets. So as some of these exoplanets are passing around in front of their stars, some of that starlight is actually going through the atmosphere of those planets. And then we can actually use that starlight passing through the atmosphere and coming then to us to understand more about the actual chemistry of those atmospheres. And some of our upcoming space telescopes, the James Webb Space Telescope, the LaVoir instrument, a lot of these upcoming space-based telescopes, I think, are going to make some huge differences. I personally think in a few decades from now that the level of resolution that we'll have with our space telescopes to look at the atmospheres of exoplanets is going to be outrageously, incredibly capable to show us what's out there. And honestly, if there is life out there, if life is common in the universe beyond our planet, then I think it's only a matter of time till we discover signs of life in an atmosphere of an exoplanet.
That is so fascinating because, of course, right now, our potential to understand the chemistry of the atmospheres of exoplanets is still a bit limited, but you are saying this is going to increase pretty fast. But question, so when this becomes way more powerful, our capacity to understand the chemical signatures in the atmospheres of exoplanets, do you think that will be enough without going there with robotic probes, which we cannot anyway because they are light years away? I mean, will that be enough to understand the existence of life forms remotely through the telescopes in a few decades? What do you think?
Yeah, so if we say we look at the atmosphere and we find some signs of chemical disequilibria, so variations in the chemistry that can't be explained naturally, at least as far as we know from a natural process.
Okay.
That still won't necessarily mean that it's alien life,
Exactly.
but it will be a better reason for us to then start looking more consistently at this place where we've found this potential sign. So when it comes to making a solid detection of alien life, a lot of us agree that it can't just be one single biosignature. It has to be a connection of various biosignatures that can then point to that alien life. But you're right. I mean, maybe we'll find what very, very, very likely looks like an alien biosphere from atmospheric biosignatures, but not be able to travel to that world for a very long time to actually make a true detection and see that life. And that would be it'd be disheartening a little bit, but we would still have then, I think, better reason and better cause to then ask people, we've found this potential sign of alien life. Can we get more support, more funding, more resources to build bigger and better telescopes to get a better look at that thing? But it is very hard to say, we found alien life through just telescopic observations. So having robots would be even better. But then even on top of that, then having humans go and take a sample and bring it back for us to study would be even better if possible.
Yes.
So it gets hard. That also then kind of takes us to the technosignature realm, though, which has been an interest of mine since I was a very young kid, and I watched the movie Contact.
Technosignatures, yes.
This idea of SETI, could we ever receive communications from the alien species? And that would be a bit different. So if we actually received a message and that we actually could translate and somehow understand what this message is saying, even if it wasn't intended for us, that would be a game changer as well. And so it's definitely worth considering what signs of technological advancement could we discover, and could we actually find a message from an alien biosphere?
It is fascinating. I mean, first of all, as you said, these things take a lot of work and a lot of time. The other day, I was listening about the ocean in Europa, that they first got first hints from this probe, but they could not confirm it completely. Then they got a secondary hints, but still not completely. Now they got the third after studying all the data, and now they have like 3 different ones, as you say, combining multiple evidences. And now they say, okay, now almost for sure, it's confirmed that the ocean is right there. But as you say, it takes multiple amounts of evidence data. And the technosignature. Oh yeah, I mean, I used to dream when I was little that one of these messages arrived, and then a competition was organized around the planet for all the children and everybody to try to decipher this message. So I think this is a dream for many of us that this will happen. Yeah,
it's very cool. Yeah, it would be very incredible too if it was a child or a young person who was able to decipher the message. Young people are just as capable at getting involved in science and engineering,
or more, right? Or more, because they don't have the tunnel vision, right? That we sometimes have. They have a much more open mind in many ways.
Yeah, sometimes you have to think like a child a little bit and be more willing to overcome your own fears and biases that we adults are taught to hold.
Yeah, totally agree. Okay, so let's now suppose that we do find and we come in contact with one of these new life forms. Now, communication. What kind of strategies do you think we would have to use or plan to look for a mutual understanding if we have such a different arrangement even, or we're so different? What kind of strategies would we look for to arrive to mutual understanding?
Many of us have considered, if we do find an intelligent alien species out there and we want to communicate, at what levels could we actually potentially communicate? Exactly. And the issue is, our languages, our culture, our history is very based on our place here on Earth.
Exactly.
Even, we talk about mathematics a lot and using mathematics to speak to each other.
Mhm.
But even that could be difficult because even our mathematics, the language of our mathematics at least,
Hmm.
is very based on how we've developed it through time and how we understand it. There
Yeah.
could be concepts in mathematics that we haven't uncovered yet that alien species might have gotten to, and
Mhm.
vice versa, that would make it somewhat difficult to actually have a mathematical conversation. And then beyond that, there are potentials that our biology could be very, very different, so radically different
Mhm.
that we have a hard time really understanding each other's perspective of the universe. So one example
Hmm.
I've given a lot lately, and it's an idea I've been thinking about a lot. So we are heterotrophic organisms. We require taking in the materials created by other organisms, the carbon-based molecules from other
Uh-huh.
organisms, to
Uh-huh.
make our own molecules.
Yeah,
So
through
you need to
food.
have some salad. You need to have
Yes.
vegetables or some meat or nuts.
And
You need
metabolism. Yeah.
Yeah, you need to, I mean, we have to eat other organisms.
Yes.
It's part of our biology. We have to eat other organisms to live.
Mhm.
However, there are organisms in our biosphere who are not that way. They
Mm.
take in their carbon by breathing in carbon dioxide,
Oh.
and they use that carbon dioxide to make their carbon inside of their own bodies, inside their
Oh.
cells. So
Interesting.
what happens if we meet an alien biosphere that is entirely, and the word for that is autotrophic, they're entirely autotrophic. They bring in
Mhm.
their carbon source from non-organic sources. They don't have to eat other organisms to stay
Mm.
alive.
That's so
If
interesting.
that were the case, and we started to try to communicate to each other, but
Uh-huh.
we're so very different, even at the basic biological metabolic levels,
Mhm.
would that really impact how we see ourselves in the cosmos? To the point where, what if such a creature, such an alien race, thinks of
Hmm.
us as evil because of the fact that we eat other organisms?
Ooh, that's very, very interesting.
Wouldn't
Yeah.
that be unfortunate if we were judged by our basic biological metabolism
Yeah.
before we even have a chance to communicate to each other about
Ooh.
what we understand about the universe? And so it's kind of, it's an interesting thought experiment.
Mm.
I don't know if it's
Mm.
possible or not. Um, but it's an interesting thing to consider. Maybe we would be so different biologically from other creatures that
Mm.
all of our fundamental understanding of language, of even mathematics, could be very different, to the point where we just can't communicate at all. And that would be unfortunate.
Wow.
I don't think that's going to be the case. I think
Mm,
we're
you don't
very
think?
likely to meet another species out there
Mm.
who has at least some semblance of the same understanding of the universe that we do.
Yeah.
Uh, Seems more sensible that that would be the case. But it's important to remind ourselves that it's not necessarily true.
That is so fascinating. You trigger two things in me. One, is there already a group of people that are dedicated to study these potential future forms of communication with new kinds of life forms? And two, is there anything we could learn of our attempts to communicate with existing species on Earth that are very different to us, like, I don't know, an octopus or whatever?
Absolutely, there have been folks working in that realm actually for quite some time now.
Mm-hmm.
At the SETI Institute, there are folks who have been doing this work. Various researchers around the globe working in the realm of communication and linguistics, as well as in the sciences and astrobiology, have been trying to understand how communication works between species on this kind of level.
Yeah.
And they've been wondering, how would we communicate? People have tried to create mock languages of potential alien beings based on
Huh.
different biochemistries and planetary alignments and things like that to figure out how we would communicate. People have considered what type of mathematics, what from our knowledge of mathematics, of the language that we use to understand the universe, would we most likely have in common with other beings that
Mm.
we could use as a basis to start communicating. And there have been a lot of folks lately, especially, who've been doing research into the realm of can we communicate with other beings on Earth who appear intelligent as well, from dolphins and other
Yes.
primates, of course, apes, chimpanzees, but also octopuses are a great example of a very intelligent being
Hmm.
on Earth. We think that we would wonder, like, can we communicate with them?
Yeah.
And even though I'm not personally doing that research myself,
Hmm.
it's a very cool area of
Yeah.
research, and it's cool to think, maybe from this area, maybe we'll start having communication interspecies communication here on Earth
Yeah,
first,
back
or
from
we
that. Yeah.
start communicating with alien life somewhere else.
I think this is a dream for a lot of people, that we could be able to communicate with other species on Earth in more powerful ways. It is interesting that research could bring back benefits for that. Wow, that's fascinating. So talking about the species and behaviors, as you have seen so many and you study life here on Earth, what is the most fascinating behavior of a life form that you have ever encountered? Or one of them?
I love that question. So one of my favorite things to think about are the craziest creatures on Earth, the weirdness of life on Earth, the wackiest things that life appears to do. We humans actually are one of the best examples, personally. We humans have developed a technological civilization of sorts, to the point where we are now impacting our planet in ways that no other species ever has in the past. And we're now becoming thoughtful enough about ourselves that some of us think there could be a future where we are more positively impacting our world and our place on it. But if you look back at our history, I mean, the development of language, of religion, of culture, of music and art, and all these different things that we've done, it's incredible. And it gives me hope for other alien species out there. But if we start looking at some of the other weird things on Earth, there are microbes out there that can send little pieces of their cells kind of out into the nether worlds, these little wires that can connect and conduct electricity outside of the cell to allow them to run their metabolisms. There are organisms that are thriving in these very weird.
Wait. That first one, I want to understand. That's fascinating. You mean there is this creature that sends outside of itself this what?
It's basically a wire. It's a little filament, basically, and the cells can use that to basically conduct electricity to allow electrons to move. So around the atom. So in the nucleus of the atom, you have your protons and neutrons, and around the outside of that, in this big space around the nucleus, is where electrons reside. And a lot of what life is doing, metabolism, a lot of how life is getting energy is by moving those electrons from one atom or one molecule to another. And it's that process of moving electrons around, of conducting electricity, of moving electrons, that allows life as we know it to function. It's the basis of metabolism.
So it's all electricity in a way,
Exactly. It's all kind of this electrical conductance in a way that life is using the transition of these electrons from one molecule to another, using the extra energy from that to then power reactions to move forward. And so some of these cells we're now discovering can do part of this process outside of the cell, far away from the surface and the interior of the cell. And that's really cool.
That's amazing.
And there's so many just weird metabolisms and biologies out there that we're learning more and more about.
Tell us more. Tell us other wacky ones.
Yeah, so a lot of my talks I've given about weird creatures, to make it easier for people to understand, I talk a lot about plants and animals and fungi and things like that, because they're very similar to us and we understand them very well. So one of my favorite ones to talk about is actually the hummingbird. Hummingbirds are very beautiful creatures that have very crazy metabolisms. So the hummingbird, about 25% roughly of the hummingbird's muscular mass is inside of its chest, because it needs its big chest muscles to beat its wings so fast. So their wings are beating very fast. They can fly up and down, sideways, front and back. They can also fly upside down. They're beating their wings so quickly that their hearts have to beat very, very, very fast. Now, in order for the hummingbird to flap its wings so quickly and so much, it needs to have a very large caloric intake. Now, for a hummingbird, they're very small birds. The smallest bird on the planet is a hummingbird. They're very small birds. And so for most of them, they're taking in a very small number of calories each day in nectar. But if you transition the number of calories per unit of body weight of a hummingbird and compare that to a human being, then the hummingbird is somewhere around 77 times the caloric requirement that we human beings have per unit body weight. Which means that if we humans had that metabolism, we'd have to eat around 155,000 calories a day just to stay alive.
Wow.
And so then that's a very large amount, so much so that it's just beyond imagination of how much food we would have to consume all day, every day, just to...
And this is just because they need to flap the wings so fast.
They flap their wings so hard.
They need way more energy.
And when they're not doing that, when they're not flapping their wings super hard to maintain their bodies and to not just die because of this bizarre caloric requirement, they then can basically shut themselves down. They go into a state of rest called a torpor, where it's very close to death. It's very calming inside. It's almost like a hibernation that they have to go into when they're sleeping and when they're calm, because otherwise their muscles just require so much energy to move. And I find that bizarre and incredible. I think about deep sea organisms a lot too. There are so many crazy organisms living on the deep sea. If you go down to hydrothermal vents, these black smokers in the ocean floor where ocean water has gone down into the crust under the ocean, has been heated by the magma down below, and then comes back up and forms these large chimneys where minerals are forming these big structures and big black smoke is pouring out, and there's a lot of chemistry, a lot of heat for organisms to use for life. We find these giant tube worms living around these things, albino crabs, all kinds of microbes thriving in these environments. It's a bizarre environment compared to what we know here on the surface. And then we also have down in the deep sea all these just bizarre looking organisms like anglerfish and things like that are using phosphorescence in various ways and bioluminescence in various ways to attract prey and to communicate. And it's just life on Earth has done so many cool things. There are so many creatures around the planet that we could talk about that just do really weird things that give us a lot of ideas that if we do meet an alien biosphere out there, we have no reason to think that biosphere would just be one organism. So if we find alien life, we're not just looking for one thing in that alien life. We're looking for the biosphere that created that alien life. And so then it must also be complex and full of different kinds of creatures working together.
Wow! Really, you blew me away with this this crazy, wacky, unusual kind of creatures and species. But I'm sure we can also, and the people who study them, we can eventually learn and get inspired by this diversity and get ideas maybe to incorporate in our processes in medicine and in other fields. And I'm sure that there are people doing this.
Oh, absolutely. In biochemistry and biomedicine, biomedical engineering, there are a lot of folks who are looking at what biology has done around our planet that we can use for making medicines, for creating new materials. For instance, for a very long time, we've been wondering, like, could spider silk, for instance, become a new fabric for us to use because it's a very strong fiber that spiders create biologically. And there's a lot of reasons to think that in the very near future, it'll become even easier for us to create biological machines that can recreate what life has already done here on the planet for us en masse for our engineering, for our construction, for making new materials. Who knows, maybe our spacecraft in the future won't have to be as rigid of structures. Maybe they'll be able to flex and bend more because they're based on biological materials and things like that. So
yes, please. I'm tired of these rigid walls.
Yeah, it's hard to say, right? And there's a lot of crazy, awesome things that life has done already, and that can inspire us to also then learn new things that are possible. And one place I'm really interested in is material science for helping us to build a better world into the future, especially using organic biological materials in our construction.
Exactly. Do you think that now that we are beginning the age of nanotechnology and artificial intelligence, well, we are deep into the age of deep learning, machine learning and stuff, do you think this process is going to accelerate now? The process of being able to incorporate some of these discoveries into real uses like construction or whatever?
Not only do I think it's going to grow exponentially in our understanding of the materials and the technology, but I think given what's happening right now, for instance, in the world, with all of the physical isolation,
Yes.
and with people realizing that a lot of our systems haven't been functioning well, that we do need better regenerative systems on our planet. We need to be better, not just stewards of our biosphere, we need to be better members of our
Yes.
biosphere. We need to start treating our world and our fellow organisms on this world with more respect, and we need to treat ourselves with more respect. And I think developing building materials and construction methods that are more sustainable and ecologically sound will also incorporate new kinds of materials that themselves are regenerative and sustainable, that can use some of our knowledge of biology to make our buildings not only strong and structurally sound, but to also use the energy of the sun to power our lives, more than having to go out and burn fossil fuels and things like that. I think we're going to start seeing a lot more of that coming out of this pandemic. I think one thing I've noticed a lot personally is that a lot of people now are getting more interested in the overview, in looking down at our Earth as a rock in space where we're all together now in this thing. And we have to be able to work together when things go bad, but we also have to be able to work together to make things better.
This is very good. And so do you agree then, because I've read a few articles in the last days saying that all of this pandemic, the origin, the root, the deep root of it is in the destruction of the natural world and the invasive behavior of human beings in relation to nature and the natural world. Do you agree with that? Is that part of the problem?
That's a hard one to kind of wrap your head around. I don't think I actually agree with that.
Okay.
And here's why. So viruses and even pathogenic bacteria, to our knowledge, have been with us for a very long time. We actually don't even know how long. So the flu, for instance, influenza that causes the flu, we've known at least for a few hundred years for sure that the flu has been around. But we can look back in some ancient texts, and there are historians out there who see signs of what looks like pandemics and things caused by viruses in ancient times, but before our written records and our understanding of medicine really grew to the point where we could understand this. It's only been a few hundred years that we've really understood that, you know, that there microscopic organisms existed out there, let alone that these very small biological machines called viruses exist. And so we're only just, you know, now understanding that it's very likely that things that can harm us, that can use our biology for their own benefit, have likely been with us since humans have been around. And so we've always had this, not just since industrialization on our planet. We've always had pandemics and plagues and issues that can harm us. Now, one of the issues I've seen, though, with this pandemic, and I think a lot of us have noticed, is this hesitancy from governments especially, but from also various interest groups around the world. There's been a hesitancy to act, to work together against the pandemic, to try to save lives and to work together to make it better. And a large part of that is because of how we've developed our political and economic systems to benefit a very small few. And I think that's part of the root issue, and also how we've been acting towards our planet. We've been, you know, too careless in how we extract resources. We've been too thoughtless in how we proceed in generating energy for ourselves to have lives of comfort. And a big part of that is because it's very easy for us humans to quickly allow power and wealth go to our heads. And to forget that there are others who don't have the same positions of comfort and safety and luxury, who are working and toiling to give people those lives of luxury. And so even though this I don't think this pandemic was caused by our poor actions on the planet, I hope, my true hope from the pandemic is that this pandemic in and of itself will cause us to then want to be better and to actually start acting better.
That's beautiful. That's beautiful. So you really pointed out is a combination. There are political factors. There is the not having enough empathy with the planet. Sometimes there is a combination of factors. But as you say, if this serves as the trigger to improve our relationship and our empathy with the planet and everything, would be wonderful. Wonderful, wonderful. And now that we've talked about so many interesting species, let's go, already moving towards the end, to the topic of what happens within the thinking or whatever, or the brain, if there is a brain, circuits of some of these species. Let's go to consciousness, which is maybe the biggest mystery in the universe. And for us humans, there are like two fields regarding consciousness. There are the people who think that is part of the fabric of our neurons, our brain circuits, and people who talk about the Panpsychism perspective, that is like a essential layer property of the universe that we connect to somehow. On what side are you on of these two?
Well, I think when it comes to panpsychism versus a very reductionist approach of consciousness only coming from the material inside of our minds, I think it's more than just those two. I mean, there's certainly a spectrum of ideas. But I think going back to the very basic question, what is consciousness? We don't know.
We don't know. That is the problem. Nobody knows.
So as an astrobiologist, we have this issue when it comes to saying, like, what is life?
Yeah.
We don't even know that. So there have been...
There is not even... Is there a definition of life everybody agrees on or not?
No. So there have been several hundred attempts at a definition of life.
Wow.
There's one right now. It's called the NASA definition of life, even though it was never actually like taken by NASA as the official definition, but it came out of a NASA working group. And that definition works fairly well for our needs. So we have these ideas that life is a self-contained chemical system that's capable of undergoing Darwinian evolution. That's it, right? Basic idea of what life kind of is as far as we know based on life.
So it has to be Darwinian evolution and self-containment within some kind of whatever membrane or whatever. Yeah.
But even that gets a little tricky then, right? Because what is a self-contained system?
Yeah, exactly. It could be many things. Yeah.
Because then is a whole planet a single organism, because it's all self-contained inside of a planet. And so you have a lot of questions that start coming up there with the Gaia hypothesis and all these other realms of study. But when it comes down to it, maybe we can't define life. Maybe that NASA definition is basically a working definition.
Yes.
It allows us to go into the laboratory, into the field, to take spacecraft to other planets and do astrobiology, to ask these questions. But from a very philosophical standpoint, we're still not really entirely sure of what life is. And so when you go then to the next level of what is consciousness, I mean, that goes to some very deep philosophical questions that humans have been asking ourselves since we knew how to ask ourselves questions. Not only why are we here and are we alone, but what are we? Why are we thinking? Are other humans around me also capable of understanding and thinking the same way that I do?
Yeah, exactly. Is it the same kind of experience or not?
Yeah, and we just don't know. Now, from a scientific standpoint, so science is very much a tool. It's a tool that we humans use to better understand our place in the cosmos and how the universe works. But it very much requires empiricism. We need evidence. We need objective evidence that multiple people can see, can observe in some manner, and then can use to make interpretations about how the universe functions. Now, the idea of panpsychism is really cool. I kind of dig it. This idea that consciousness could be everywhere, and maybe what we feel as consciousness isn't just inside of our brains and our biology, but is actually part of the development of our minds, to the point where we're now biologically able to tap into something out there that we can't actually observe scientifically. The idea is beautiful. And I would never say it's impossible, But the unfortunate part right now is that with our current science, we can't say whether or not it's probable. And so we have no way to observe that right now. And so it lies beyond the realm of science. And so there's a lot of these ideas, things in our world that we've considered for a long time that we cannot test scientifically. There are other ways to understand who and what we are in the universe. And so the ideas of consciousness, I think we're only just beginning to understand.
And there are two kinds of opinions regarding if we will ever be able to understand consciousness. There are people who say never, others eventually yes. Do you think eventually yes or never?
I'm definitely an optimist in that realm. I think yes, but I'll throw out a caveat.
Okay.
I think that we will eventually be able to better understand what consciousness is, and maybe even nail it down and say this is consciousness, and maybe even this is life. Once we have other examples of life and other examples of consciousness to work from.
Okay.
However, when I say we, I really mean we as in our biosphere, so Terran life, because maybe what we currently are as humans won't be around anymore at that point. And I think we should accept that there's a chance that we will replace ourselves with a post-biological life form, an artificial intelligence, or even just another version of ourselves that we've actually genetically, biologically engineered to be a different version of the human 2.0. And maybe that organism, which will still be part of the biosphere, part of we, will be the one who figures it out. And so that's my caption.
That's very interesting. If you were in front of a new type of life form, and that new type of life form told you that it is conscious, could you prove if that's true or not?
That's a fun question. That goes, again, back to philosophy. There's this idea in philosophy, the very basic idea of a zombie in philosophy.
Yes.
Is, we all are walking around in this world. We see people all the time around us. How do you know that anyone else is actually a conscious human being?
Exactly.
And the problem is that you kind of don't. You kind of have to assume that other people are also conscious and also capable of the same kind of internal monologue and the same kind of thought processes.
Because they look similar to us,
Yeah, we are all similar. And so right now I'm looking in my camera and connecting to you from a different part of the planet. I'm assuming that you're a real human being and not just a computer-created digital representation of a human being. And I'm assuming that you're conscious. I'm also assuming that I'm conscious.
Yeah.
And so it starts to really make your head go for a really fun dance when you start asking yourself these questions about whether or not we are conscious.
Exactly.
And so if we meet another alien species and they say that they're conscious of their place in the universe, it's gonna take us some work. But the beauty of communication, of us actually finally meeting another intelligent alien species, would be that we would then have each other's notes to work from. So we would have our own examples from our own philosophy and history and science, and we can assume that they would have their own examples of how they've tried to frame their place in the cosmos. And coming to the table together might help us to better solve some of those problems.
I really, really love this. One of the most beautiful things I'm getting from this conversation with you is that when we come in contact with other life forms, the kinds of things that we will be able to learn and to get from that communication back to many things that we were looking for a long time is way, way larger and way more expansive than I had ever thought. This is fascinating. And this connects with this last question, which is, there is a topic that fascinates me, which is, are we like machines? Are we just computational, kind of like computational entities? As you study life, and you're an expert in studying life forms, and as you study more and more life forms, how is evolving your sense of, are all life forms just kind of sort of computational machines? Is this all that is going, when we look at the DNA, kind of like the software of life and everything, is it all at the end sort of like these computational machines, Or what do you think?
Yeah, so it's interesting. We look at the biology that we understand for life as we know it,
Hmm.
and it does appear to function like a machine.
Mm-hmm.
It has certain inputs. There are certain processes that it will conduct, and it
Mm-hmm.
has certain outputs.
Yes.
But life would be a very complex machine, obviously, because life does a lot of really intriguing things on our planet.
Yes.
Life and the fact that life evolves, that life has this process for mutation and for
Mm-hmm.
adaptation and for evolving to find ways to fit into new systems, makes life a very powerful machine. But
Mm-hmm.
as I mentioned earlier, we don't actually even have a definition of what life is
Yeah.
yet. And that kind of is an interesting thing for right now during a pandemic with a virus, because we have had a lot of issues in figuring out whether or not we should consider viruses alive.
Oh yeah, I was gonna tell you that before, that a lot of people these days are saying, but really, I mean, these whatever that are making such a mess, are they really not alive?
Yeah, and so that's a question, right? So a virus is a self-contained chemical system,
Mm-hmm.
and viruses do undergo evolution. They do
Okay.
adapt through time through
Mm-hmm.
processes of selection.
Yeah.
And so viruses can be considered to be alive by many people. But we also think of viruses as biological machines.
Hmm.
And when we start thinking in that kind of way, that viruses are biological machines, they are developed to do one thing, to
Hmm.
infect a host to create new viruses. And that's what a virus does. A virus is a small self-contained system
Hmm.
that carries inside of it some genetic material, and that genetic material allows the virus to infect host cells and then create new virus. And so that is very much a
That
biological machine.
sounds like a machine, really. Yeah.
Yeah. And so at its very basic level, viruses are telling us that life is a machine, that life is processed the same way that we create machines ourselves.
Hmm.
And interestingly, that makes us then consider for artificial intelligence and for the future, will we start creating machines that themselves undergo Darwinian evolution in a sense, and that
Interesting.
themselves start developing technology and maybe even consciousness? And so we have to consider, when we look out in the universe, will we start meeting a lot of other species who themselves are post-biological? They went
Hmm.
through a period of biological machinery, of biological evolution, and are now in a period of what happens next,
Interesting.
of artificial intelligence, of synthetic life, of life created from life, but not of organic materials necessarily. And so
Hmm.
there's a lot of potential out there. And I think one of the beautiful things about astrobiology in general, and like I mentioned when we first started, astrobiology is a huge field.
Yes.
And it's not just science. There are scientists from all these different disciplines in biology and chemistry and astrophysics and all these different realms of study. But astrobiology is also about philosophy. It's
Hmm.
about asking these really big questions about
Because.
ourself and our place in the universe.
Hmm.
And to really start getting around those questions, we need a lot of different perspectives. And so having more people get involved in the conversation is
Mm-hmm.
one of the best ways for us to bring our different backgrounds, our different perspectives to the table to start asking these big questions together. And we might not ever, during our lifetimes, find suitable answers, but
Mm-hmm.
we at least might go down a path of having some answers that lead us to even grander questions.
Well, that is a beautiful call, and we invite all the audience. We hope that a lot of people that listen to you, especially new generations, will get very inspired by you and will join this beautiful quest on answering the most fascinating questions in life and in the universe. And yeah, this is what you said about creating new kinds of life forms that can evolve. Reminds me of reinforcement learning in artificial intelligence, where we are already doing that, but with code, and a lot of people are talking about, well, eventually we're going to combine this AI code with biology, and then some of these things that you're talking about will begin happening. That's very interesting. So to finish, Graham, the easiest question I'm going to do to you to finish, the easiest question for the end is, what is for you? Because I'm always curious with interesting people like you, what is for you the meaning of life? what is for you what gives life purpose and meaning? There we go.
It's a powerful question,
Yes.
and one that can take you in so many different directions. So for me, I've never gone to space. Less than 600 people on our planet so far in our history have left our planet and have traveled past the Kármán line, roughly 100 kilometers, and have gone into orbit or have even gone to the moon or orbited the moon. However, this idea of the overview effect, this idea that it was coined by Frank White in 1987, this idea that a psychological shift can happen in humans when they see our world from space, that they start to better understand our togetherness on this little rock, that we are part of a larger biosphere. I find a lot of meaning in that for myself. It's part of the reason why on a near daily basis, I like to look at images like Earthrise, the blue marble, the pale blue dot. I like to think about our togetherness. I'm a meditator. I have a practice of meditation. I meditate at least once a day. And one thing in my meditations that I find a lot of purpose with is just being with myself. But also during many of my meditations, I like to have a little time to just feel my connectedness to not just other humans, but to the planet. And so for me, the meaning of life, the way I find purpose, at least in my own life, is through feeling not just like I'm Dr. Graham Lau, not just like feeling like I'm, a human being in my communities here locally and globally, but by feeling connected to all of life on this rock, and to the rock itself. Our planet isn't just the physical material that holds the biosphere, it is the biosphere. Our Earth is what we are. And so for me, I find a lot of meaning and a lot of purpose for myself in reminding myself that regardless of how hard my own life seems, or regardless of any tragedy or pain or suffering in our world, that when it comes down to it, we are still our biosphere. We are Earth. And I find a lot of comfort in remembering that even when I die, whether or not there's an afterlife, I don't personally believe in an afterlife, but I would never tell someone that they shouldn't believe it. But for me, I find comfort in the feeling that when I no longer am conscious of life, when I have died, that the material of my being will still be part of this biosphere.
Beautiful, absolutely beautiful, very deep. This connectedness that you have so beautifully described. I could not imagine a more beautiful way of completing this beautiful conversation. Graham, you have inspired me enormously. Thank you so much for connecting to the spacecraft today. And I think you will inspire a lot of people that watch this conversation. Thank you so much, Graham.
I truly appreciate it. Thank you very much.
Thank you for following the Beyond podcast. If you enjoy it, subscribe on YouTube and support it in other channels like Patreon and others. And hope to see you soon at the Beyond podcast. Thank you.